In the last video, I talked about trying to describe atoms in an ideal gas. Well, I'm going to turn the tables a little bit today, and I'm going to talk about the way that we learn about things. The way we learn about things is we ask a question, and that question leads to another question, and that leads to another question, that leads to another question. So, what are the questions that I asked myself and led to other questions that I asked myself again? The first question was for this video was an atom. How do we talk about an atom? We probably know that there are protons, electrons, neutrons, and there's the atom, and that's all we need to know. But what what do we describe about those electrons, neutrons, and protons? How do they all fit together? The discipline to talk about the atom is quantum mechanics. Quantum mechanics, which usually stops people dead in their tracks. And that's pretty much what happened to me. Was quantum mechanics was this mysterious thing that unless you were a math genius you could never understand. So what I did is I started a course in quantum mechanics, and one of the first things it mentioned was Planck's constant, but it didn't mention how Planck's constant came into being or what it means. So, what I did is I asked myself was, well, where did Planck's constant come from? How did this all occur? And then I find out that Max Planck was looking at black body radiation, which I've had some videos about black body radiation, and it came to a certain point and it just stopped because I didn't have any more answers to give. So, what happens next is I looked at Planck's constant and I looked at the black body radiation formula that Max Planck proposed, or actually it's quite accepted now, and I drew a blank because there were all these symbols. There was the uh, natural logarithm base and all these things in this equation, and I thought, well, where does all this stuff come from? So that added another question that said, where did Max Planck change the existing formula for black body radiation into the one that's accepted now? This led me back into some questions about where Boltzmann's constant came from. And then I looked at Boltzmann's constant, and that came from yet another constant, a gas constant, from the uh, relationship between pressure, volume, and temperature of an ideal gas. Like that last video, I talked about an ideal gas. So that constant, which was recognized formally by Planck, but Boltzmann, who was the guy that talked about thermodynamics, came up with some of his concepts. So that led me back into thermodynamics. In thermodynamics, I find out there is a Boltzmann's equation that relates energies of atoms and probabilities, which is what I promised to do in the previous video. So if I look at that relationships, I come up with something that's very close, or it's very closely related to Max Planck's, I got to say his name correctly, Planck, I don't know, he's German, so how do we say it? It's hard to say. But anyway, his ideas are related to the Boltzmann equation, which which I have found in uh, information talking about thermodynamics. So actually, Max Planck said, hey, what if there are photons, or if there are individual discrete energy packets, just like moving atoms in a gas? Let's put this whole thing together and see if it matches the measured reality of black body radiation. And this led to some more math equations that put this form in a place that if we make the discrete energies super, super small, they match the Rayleigh-Jeans relationship, which matched all of this stuff. Now, this video is a lot different than my other ones because I don't know what I'm talking about. And that's when learning occurs, is when you say, where are the gaps in my learning so that I can move forward? So what I'm going to try to do is take this information and put it into symbols that you can look at on a shared screen, and we can talk through this stuff together.